Okay. So the vibration, there's peaks and valleys as the RPM goes up and down. I think the areas with the least vibration, there's a couple nulls, but the major one is actually almost at the very highest upper end of the RPM band. So probably around 40,000 is where the least vibration occurs. And this heatsink I made here, it seems like the motor's not getting as hot as I was expecting, which is really good. Like after about a minute or two of running it at high, about a minute of running it high, it's still maybe 40 degrees. You can touch it and it feels warm but not hot. Well, yeah. This here actually was hotter than I was expecting. I guess the bearings are really what's going to create more heat. The motor here, the heatsink's taking care of that, but these bearings here spin and they actually get hotter than the motor. And so I might have to put a heatsink on the bottom here. But overall I'm pretty impressed. I'm pretty pleased with it. I think I might have to do another cutting gantry with a belt drive. I hear that's a little bit nicer. You can run the motors at lower RPM, find more easy to find motors, and then use a belt to change the RPM for the spindle, and you get hopefully some vibration damping. But this is pretty satisfying for a first try. I'm going to have this hopefully mounted on the machine with all the other motors ready to go in the next few days here. And then we got to do the software, and we got to house this. I picked up a housing for all my electronics from work. They were going to throw it out. I work at a oil field control panel manufacturing company, and they're just going to throw out this panel, so I took it and I'm going to use it to house all this equipment, all the electronics. Oh yeah, and the beeping sound it makes is much louder when the motor's attached to this spindle here. It must amplify it. And it's time to safely discharge my capacitor. So we don't want the capacitor to stay charged. There you have it.